Hey guys, welcome to another video. So in the last video, we have already spoken about angle of attack and the angle of incidence. Now in this video, I would like to link angle of attack and the shape of the aerofoil. Now when it comes to the shape of the aerofoil, we remember that there are two basic shapes when it comes to an aerofoil, which is symmetrical and asymmetrical. Now there are a lot of hybrid aerofoils and all these things that has come into play, but we would like to keep it simple. We would like to talk about the basics, and we will talk about symmetrical and asymmetrical aerofoils, and we will talk about how angle of attack really affects it and how it is linked to lift. Right? So first things first, basic things. When you draw a line through a symmetrical aerofoil, it gives you two equal halves. It will give you two equal slices, and that's why it's symmetrical. And when it comes to asymmetrical, if you draw a line between through an asymmetrical aerofoil, it won't give two equal halves, and that is why it is asymmetrical, right? Now I've drawn this diagram, and the top two is indicating a symmetrical aerofoil, and the bottom two is indicating an asymmetrical aerofoil, right? So in the top two aerofoils, symmetrical, my diagram isn't very accurate, but I hope it explains, and as I speak, we'll understand it better. So top two, basically I'm drawing a line in between, and it is giving me two equal halves, and again, you can see that it's a symmetrical aerofoil in the top two aerofoils, and it is two different situations that I want to explain. Now, in the top aerofoil, in this aerofoil, you can see that the angle of attack is zero. Basically, what I mean to say that the chord line is in, and chord line and the relative airflow is making a zero angle. Relative airflow is this air that is coming in as the aerofoil moves forward, right? And this is the chord line. So what I mean to say that the angle of attack is zero in this particular case. Now when the angle of attack is zero when it comes to a symmetrical aerofoil, the lift it creates will be more or less zero, right? And let's say if the angle of attack is negative, it has to create negative lift. That is what it is meant. Now in this particular case, the angle of attack is increased, or it is pitched up basically. So as the angle of attack is increased, what all is happening? You can see that more air is being forced to flow below the aerofoil. Now again, I want to remind you, lift is what? Lift is a differential, a pressure differential. So only if high pressure is created below the aerofoil, there would be more lift, right? More high pressure below the aerofoil, more the lift. So there's low pressure above, high pressure below, and this pressure differential creates lift, right? So as the air is moving inside, as the, let's say the angle of attack is increased and more air gets to move in, what happens is that more air is slowed down below the aerofoil, and as air gets slowed down below the aerofoil, we remember the law of conservation of energy, and it creates more pressure, and there is more surface area as well, if you can see. So as air is forced to flow below the aerofoil, it creates an upward push from below, and the symmetrical aerofoil is basically getting more lift, or lift is being created. So positive lift when it comes to positive angle of attack, negative lift when it comes to negative angle of attack, and zero lift when it comes to zero angle of attack when it comes to a symmetrical aerofoil. But this is all a very theoretical thing. In reality, things might be very different, but for your exam purpose, this is what it is. Now let's talk about, I cut it off a bit. Okay, so let's talk about an asymmetrical aerofoil, or the bottom two diagrams, right? So what is happening here? You can see that as the chord cuts it, two different, it's an asymmetrical aerofoil. I've explained it quite a few times, I think. So as air is flowing across an aerofoil. The only difference between an asymmetrical aerofoil and a symmetrical aerofoil is of course its shape, but one of the major differences in my eyes is that in case of an asymmetrical aerofoil, even with a zero angle of attack, a lift can be created. Lift can be created. How can it be created? Because of its shape, basically. So because of its curvature, if you can see, air is forced to flow faster on the top side as compared to the lower side. If you can see, in case of an asymmetrical aerofoil, not in case of all, but in case of a standard conventional asymmetrical aerofoil, you can see that what happens is, let's say there is zero angle of attack. Now with zero angle of attack, as the air is flowing inwards into the aerofoil, air is made to move faster on top of the aerofoil compared to the bottom. Now that is because of the curvature of the aerofoil, or the camber of the aerofoil as we call it. And as air moves faster on the top of the aerofoil, what happens? A low pressure is created, right? And as air moves slower on the bottom of the aerofoil, what happens? Pressure is increased, or a high pressure is created, and it is pushed from bottom. Now as the angle of attack is increased, again the lift created will increase. Now one of the other things about an asymmetric aerofoil is that even with a negative angle of attack, lift can be created when it comes to it. But as we remember, in case of a symmetrical aerofoil with a negative angle of attack, it is supposed to create a negative lift, right? So the only difference is, if you want to remember it, in case of a symmetrical aerofoil with zero angle of attack, zero lift. But in case of an asymmetrical aerofoil, even with zero angle of attack, it can create a positive lift, right? So that is the basics when it comes to it. So we'll talk about more about all this more in future. We'll try to link it as we study further. I hope you're understanding something. If not, feel free to ask. Happy landings, guys. Cheers.